Welcome pre-cal students to the homework help video, page 632. Numbers 1 through 13 every other odd, numbers 15 through 25 odd, 27 through 43 every other odd, and 45, 49, 53, and 55 through 67 odd. Let's go ahead and get started with the homework help video. Let's take a look here at number 1. The directions say to use the given values to evaluate the remaining trig functions. So very quickly, I'm going to write sine, cosine, tangent, and then cosecant, secant, cotangent. And then I'm going to find out what quadrant we're in. So let's see. I want sine to give me out a positive number and cosine a negative. So that would be this quadrant here. So we're in quadrant 2. So my sine sequence is positive, negative, negative. So let's see. Sine will be positive. I guess I could put x in there. I'm not going to, but sine will be positive and cosecant will be positive, and this will be negative, 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 negative. And with that in mind, here we go. Okay, sine is square root of 3 over 2, and cosine is 1/2. So secant would be 2 over 1. And this would be 2 over square root of 3. We're going to rationalize it, and we'll get 2 square root of 3 over 3. And then, let's see, we can find tangent pretty quickly here. Tangent x would be sine over cosine, and cosine is 1/2. So tangent x is really square root of 3 over 2 times 2 over 1, and those cancel, and you get square root of 3 over 1. So negative square root of 3, and if we reciprocate that, we get 1 over square root of 3. And so if we rationalize that, we'll get square root of 3 over 3. Hope that helps. Let's move on to number 5. All right, so we have tangent and secant. Well, real quick here, students, I'm going to put sine equals, cosine equals, tangent equals, and then cosecant equals, secant equals, and then cotangent. Next, I want to find what quadrant we're in. So we want tangent when it's positive. Tangent is positive here and here. And then secant is negative, and that would be here. So we're looking at this quadrant here. And the sine sequence is negative, negative, positive. So we have negative, negative, positive, negative, negative, positive. So with that in mind, let's go ahead and use our trig functions now. Here we go. Okay, tangent is 5/12. Positive 5/12. Secant is 13 over 12. Okay, here we go. Now, if tangent of x is 5/12, then cotangent would be 12/5. If secant is negative 13/12, then cosine is negative 12/13. And I know cosine, so real quick I can find sine. I'm going to use my Pythagorean identity. Sine squared plus cosine squared, which is negative 12/13 squared, equals 1. So sine squared plus cosine squared. So sine squared plus 144 over 169 equals 1. Okay, so bring that over and make it negative. Use your graphing calculator fraction button if you need to. You're going to get sine squared x equals, let's see, 44, 54, 64, 25. So you're going to get 1 minus this would be 25 over 169. And again, use a graphing calculator if you need to, guys. Okay, 1 minus this fraction, you'll get this right here. And then take the square root of both sides. And so the square root of sine squared is sine, and the square root of 25 and 169 will be 5/13. So there we go. And we know it's negative. That's why we put our signs over here first. And so cosecant would be 13 over 5. Okay, moving on to number 9. Okay, let's see what we get here. Sine of negative x. Now, let's first of all, let's change this right here, students. If you'll look at your trig identities, whenever you have sine of negative like this, It's the exact same thing. Now watch this, please, students. Be very careful here. Whenever you have sine of negative angle, it's the same thing as putting this. Now watch. You'll see this at the bottom of your Trig Identities box. It's called the Even Odd Identities. And if you'll look, sine of negative x is the same thing as negative sine x. Now, Mr. Earhart, why are you doing that? Guys, look. In all the problems we've done so far, you have to have matching angles, and we don't. We have negative x and x. That's not going to work. Look at your last problem. We had x and x. Look at the problem before that. We had x and x. You can't use trig identities when you're dealing with two different angles. Well, except in really rare situations. So, sine of negative x is negative sine of x. Got it? Now watch this. Sine of negative x is negative sine x equals negative 1/3. Okay, so I made a substitution for this, and I put this. Now look what I have. If I have negative, it's like a negative 1 here, okay? If I have negative 1 sine x equals negative 1/3, divide both sides by negative 1, sine x really equals 1/3. Okay, guys, so you do not want to use this up here. Okay, look that over. I'm going to erase it here in a second. Look it over, okay? You want to use sine x equals 1/3. Just erase this. And let's take this, let's bring this up here in place of this, okay? All right. So here we go. Sine equals, cosine equals, tangent equals, cosecant equals, secant equals, cotangent equals, and then let's get our signs figured out here. So we want sine to be positive, that's here or here, but tangent to be negative, that's going to be here in the second quadrant. So the sign sequence in the second quadrant is positive, negative, negative. So positive, negative, negative, positive, negative, negative. Okay. And here we go. Sine is 1/3. So cosecant would be 3/1. Tangent is square root of 2/4. So over here I would have 4 over square root of 2. Now we got to rationalize that. If we rationalize it, we'll get 4 square root of 2/2. And notice these outside numbers can cancel. 1, 2. So 2 square root of 2/1. All right, 2 square root of 2/1. So 2 square root of 2/1. All right, now, okay, we're looking for cosine, and I've got sine, so real quick, I'm going to say sine squared, so 1/3 squared plus cosine squared equals 1. Okay, square 1/3, you get 1/9 plus cosine squared equals 1. Okay, bring the 1/9 over, make it negative, and you get 1 minus 1/9 is 8/9. 8/9. Then take the square root of both sides. The square root of cosine squared would be cosine. And the square root of 8 is the square root of 8, and the square root of 9 is 3. Okay, now really, students, at this point in your mathematical life, you should know how to simplify the square root of 8. The square root of 8 is 2 times 4, and we do not know the square root of 2, but we do know the square root of 4, so cross off the 4 and put a 2 on the outside. So really, instead of having square root of 8 right here, we really should have 2 square root of 2, okay? 2 square root of 2. So 2 square root of 2. So there's cosine. Cosine is 2 square root of 2/3. Now if you flip that, we got a lot of work to do. If you flip that for secant, you're going to get 3/2 square root of 2. So we multiply the top and the bottom by square root of 2, and we get 3 square root of 2 over, well, there's a 1 right here, so 2 times 1 is 2, and the square root of 2 times the square root of 2 is just 2, so you end up with 4 in the denominator. So 3 square root of 2/4. Now if I'm going too fast, you can always pause the video, okay? All right, number 13. Well, we actually did this one in our notes already, but I'm going to go ahead and do it again for you. Now look, students, anytime you get a -1 out for sine, like sine of an angle is -1 or 0 undefined, it's almost always going to be a quadrant angle. And so we're not going to worry about drawing, uh, finding out what quadrant we're in, because it's not going to help us. So let me show you what we're going to do here. All right, now here's what we're going to do, students. Watch. We know that sine of theta is -1, and we know the cotangent of theta is 0. And we know that the angle we're dealing with is either 0 or 90 or 180 or 270 or 360, okay? So I don't really need to worry about the signs, okay? But what I can do is this. Look, I know that the sine of -1, if I flip that, I get -1. And I know the reciprocal of 0 is undefined. We've learned that, okay? So all I have to find is cosine. Now, if you want to use sine squared plus cosine squared, you can do that. I would not, because it's really hard with your sines. So I'm going to use cotangent of theta equals what? It's your quotient identity. Cosine over sine. Okay? Now, watch this carefully. For cotangent, I can put 0. And for sine, I can put -1. And for cosine, I'll leave that cosine. Now, my denominator is -1, so multiply both sides by -1. 0 times -1 is 0. If you multiply this right side by -1, you're left with cosine. So there it is. Cosine of theta equals 0. And so if this is 0, then the reciprocal of secant is undefined. Okay? All right, moving on. All right, numbers. Let me turn to my book here to the directions. Numbers 15 through 20. We're doing the odds. We're going to try to match them up, okay, with something up here. So here we go. Let's take number 15 here, which is secant x cosine x. And here we go. Let's see. For secant, the reciprocal of secant is cosine, so I'm going to put 1 over cosine for secant. And then for cosine, I'm going to put cosine over 1. Look at that. And now multiply them together. Your cosines cancel. 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is 1. So there we go. So letter D is number 15. All right. Let's try number 17. We have cotangent squared. Now, I've not worked these out ahead of time, so I might have to pause the video if I get stumped here. I'm going to have to pause the video and work some of these out on my own and then come back on. So we'll see. I'm kind of going cold turkey here. All right. Let's see. Trig identities. Well, I'm thinking Pythagorean identities. There should be something. I'm looking now on my chart. There should be a Pythagorean somewhere with cotangent and cosecant. Yes, here it is. Cosecant is 1 plus cotangent. So now watch your signs. There's a negative sign here. So students, be sure and watch your signs. Okay, so cotangent squared x minus, then parentheses, and for cosecant squared, I'm going to put 1 plus cotangent. And there we go. Now, take your negative sign and multiply it through. So I have cotangent squared x minus 1 minus cotangent squared x. And look at this. Cotangent squared x minus cotangent squared x will cancel out, and you're left with -1. So letter B. All right. Okay, number 19. What do we got for number 19? Let's see. Sine of, okay. Well, sine of -x is, let me go ahead and write the problem down. Sine -x over cosine -x. Okay, here we go. Now, sine of -x is negative sine x. Cosine of -x is just positive cosine x. Now, think about this for a second, students. You have a negative over a positive, which makes the whole fraction negative, and sine over cosine is tangent. So negative tangent x. Do we have that anywhere up here? Let's see. Yep, letter E. There we go. Okay, doing pretty good. Number 21, 23, and 25. All right, 21, sine x, secant x. Now, this will be interesting. Okay, for secant, I can put the reciprocal, which would be 1 over cosine, and then I'm going to put sine over 1. All right, now let's go ahead and multiply these together. Sine times 1 would be sine. 1 times cosine would be cosine, and there we go. Sine over cosine is tangent. Do we have a tangent anywhere? Yep, right here. Letter B. Okay? All right. Number 20, 23. Now I'm thinking here we're going to have to factor probably, and here's why I'm saying that. In your trig identity sheet, you have secant and tangent squared in your Pythagorean identities, but not to the 4th power. So probably, I'm going to go ahead and skip a step. I'm going to go ahead and put this. Notice I have 2 terms, and I know the square root of both of those. So the square root of secant to the 4th would be secant squared. And I could be wrong. I'm totally doing this cold turkey. Okay, so we'll see what happens. The square root of tangent to the 4th would be tangent squared. Tangent squared, make one positive, make one negative. Now, look at your trig identities. Do we have anything? I think we do. Here's what we have. On your trig identity sheet, you're going to see this. 1 plus tangent squared equals secant squared. Now, let's see. Hey, look at this, students. Look at this. If I bring the tangent over here and make it negative, look at that. 1 equals secant squared minus tangent squared. Look what I have here. Secant squared minus tangent squared. So this whole parenthesis becomes a 1. And so this whole group here times 1 is just itself. So there's my answer. And look at that right there. Letter F, okay? So we're either getting lucky or we're doing pretty good. 1 to 2 here. All right, number 25. Now, first of all, I know I've had a lot of experience with these guys, a lot more than you have, but as soon as I look at 25 and I see secant squared minus 1, I think of the trig identity I just had here a second ago. 1 plus tangent squared equals secant squared. Now, if I bring the 1 over and make it a negative 1, then I have tangent squared equals secant squared minus 1. So, for this whole numerator, I can put tangent squared. So, tangent squared over sine squared. Now, I'm getting there, but I still don't see anything up here that matches this. But hold it, I had a thought. And I don't have many of those, okay? But I had a thought. Tangent squared is the same thing as sine over cosine, or sine squared over cosine squared. So I really have that, and then my denominator, I have this. Now, if it's okay with you guys, I can put sine squared over 1, right? Of course I can, definitely. So look at that. So tangent squared is this fraction. Sine squared is this fraction. Now, when you have a fraction over a fraction, you're dividing, but you really end up multiplying. So I have sine squared over cosine squared times, and then flip this, 1 over, look at that, sine squared. So your sine squareds cancel. 1 times 1 is 1. Cosine squared times 1 is cosine squared. And 1 over cosine, the reciprocal is secant squared. Booyah. What do we got? There it is. Letter E. All right. Okay, moving on. Okay, the directions, let me turn back in my book here. The directions for 27 say that use the fundamental trig identities to simplify. And there's more than one correct form. Okay, well, my advice to you when you're doing homework is to simplify and then compare your answer to the back of the book. Okay, that's my suggestion. So let's see how we do here. I don't have my the back of the book open, but we'll take this as far as we can. So here we go. Cotangent would be cosine over sine times the inverse of secant is cosine, so times cosine over 1. And so if we multiply those, we'll get cosine squared over sine. All right, and maybe I should turn to the back of the book. Let's see, and see how we do on these. We're doing 27 through 43, every other odd. Let me quickly pause this and turn to the back of the book to make sure that we're simplifying these as far as we can go. Hold on one second. Okay, students, I'm back here. It looks like I made a mistake, and so I apologize. Right here's my mistake, and you guys probably seen this already. Secant is 1 over cosine. There we go. Alright, there we go. So your cosine would cancel, and you end up with 1 over sine. 1 over sine theta, which the reciprocal of that is cosecant theta. And that is the answer they have in the back of the book. Alright? Okay, number 31. Okay, I'm going to rewrite the top of that fraction. Cotangent would be cosine over sine. And the reason I'm doing that, students, if I get a fraction up top and a fraction in the bottom, then I can divide the two fractions and hopefully be able to simplify. Okay, so cosecant would be 1 over sine. So I'm going to take the top fraction here divided by the bottom fraction. So really I have cosine over sine times, and I flip this bottom fraction, sine x over 1. And this is gone. These cancel, and I end up with cosine over 1, which is cosine. Let me check the back of the book here, and that is what they have. Good. Moving on to number 35. All right. Now let's think this through here. Let's see what we got. I'm going to try this one. I hope I don't make a mistake here. Let's see. Sine would be. I'm going to leave secant alone. I'm going to put x instead of trying to draw that really weird fish-looking symbol. Now this fraction here, I'm going to work with this over. I'm going to put sine x over sine over cosine. I'm just kind of experimenting here. So for tangent, I'm going to put sine over cosine. Now up here I really have sine over 1 because sine is sine over 1. So I have sine over 1 times, then flip your bottom fraction. I think this might be a good idea. Cosine over sine, so your sines cancel. So this whole fraction here became this. Now I'm simplifying. I'm getting cosine over 1 or cosine. So I really have secant times cosine. Okay? Now, secant is the reciprocal for cosine. So for secant, I'm going to put 1 over cosine times, and for cosine here, I'm going to put it over 1. And look at that. You get 1. Let me look in the back of the book. Number 35 is 1. Yes. Okay, moving on to number 39. Okay. Now, this one's going to be interesting here. Let's see. I think I see what to do. This is a really tough one, okay? Remember, students, sine squared plus cosine squared is 1. So if I bring the sine squared over and make it negative, then cosine equals 1 minus sine squared. So up top here for cosine squared, I'm going to put 1 minus sine squared. Now, the reason I did that is, see your numerator here? I can factor that. You can, Mr. Earhart? Yeah, look. I have perfect squares. I know the square root of 1, and I know the square root of sine squared. So I can factor the numerator like this. The square root of 1 is 1 and 1. The square root of sine squared is sine. And sine, make one positive, make one negative. Look at that. And and these two groups here cancel out, and you're left with 1 plus sine y. And guess what? That's exactly what they have in the back of the book. Okay, so very good. Moving on to number 43. Okay, this one could be tough. Hopefully we'll get this okay. All right, and maybe not too bad. Okay, cotangent here, I'm not for sure about this, but I'm thinking for cotangent, I should probably put cosine over sine times sine over 1. These will cancel, and I'm left with cosine of u over 1. So cosine of u. Now over here, I guess for tangent, I'm going to bring down my plus sign right here. For tangent, I guess I'd put sine over, this is pretty easy actually, sine over cosine times cosine over 1, cosine of u over 1. Your cosines cancel, and there we go. Sine of u times 1 is sine u over 1, so sine of u. And I think that's what they have in the back of the book. Yeah, that's it. We're done. So they ended with a pretty easy one. I'm surprised. Okay, let's see what number 45 says to do. Factor and then simplify. Okay, so I'm going to leave the back of the book open here so I can check these. Let's factor and then simplify. Okay, so tangent squared minus tangent squared. Okay, first of all, the first thing I noticed when we talk about factoring is that I can pull out a tangent squared. So I'm going to go ahead and pull out a tangent squared of both of these. Pull out a tangent squared, and you're left with 1 minus sine squared. Okay? Now, 1 minus sine squared is cosine squared. So now I have tangent squared times cosine squared. Okay? Now, tangent squared is sine over cosine times, look at this, cosine over 1. Multiply, these would cancel, and you're left with sine squared over 1, which is sine squared. And the answer in the back of the book is sine squared, so very good. Okay, 49, let's see here. I'm thinking we're going to factor the numerator, I think. Let's see if that helps. I have the difference of perfect squares. I know the square root of secant squared. I know the square root of 1. So the square root of secant squared is secant. The square root of 1 is 1 and 1. Make one positive, make one negative, and that's all over secant x minus 1. So these will cancel, leaving you with secant x plus 1. I hope that's the answer in the back of the book. Yes, it is. Okay, number 53. Okay, we should know how to factor this. We have the difference of perfect squares, so the square root of sine of the fourth is sine squared. And the square root of cosine to the fourth is cosine squared. Make one positive, make one negative, and now sine squared plus cosine squared is 1. So this whole parentheses here becomes a 1, and 1 times anything is just itself, and that is the answer. Yep, so there's the answer right here. All right, number 55. Okay, well, here's my suggestion to you. They say to factor and simplify. I'm going to get rid of the cosecants, and I'm going to put x cubed minus x squared minus x plus 1. Now, we've learned how to factor a 4-term expression. Pull out what's common in the first two and pull out what's common in the last two. So, I'm going to pull an x squared out of the first two, x minus 1. I'm going to pull a negative 1 out of this group. I'll leave me with an x minus 1. And now write your matching parentheses once, okay? And then you're left over with x squared minus 1. Now, I'm not sure. Let me glance here at the book. I'm going to go ahead and write my cosecants back in. So now I'm left with cosecant x minus 1. And then for this parentheses here, I'm going to put my cosecant, and of course this 2 is moved right here. Now, let's see here what else we can do quickly. I believe, yes, there's a trig substitution for this right here. For cosecant squared x minus 1, we can actually put cotangent squared. So I'm going to bring down this parentheses here. And then for this parentheses, I'm going to put cotangent squared x. And that's exactly what they have in the back of the book. Okay, so we're cruising right along. Number 57. All right, well, let's see what the directions say. Perform the multiplication and then simplify. And there's more than one correct answer. So here we go. Sine x plus cosine x times sine x plus cosine x. Alright, sine times sine is sine squared. Sine times cosine is sine cosine. And then cosine times sine would be sine cosine. And then cosine times cosine would be cosine squared. Now, students, my advice to you is to put sine squared x here, and then next put this, and then bring this down. Now that's just called rearranging your terms. It's not that big of a deal. And now notice I have sine squared plus cosine squared, that's 1, plus, and then I have sine x cosine x, sine x cosine x, so I can put 2 sine x cosine x. Let's see if that's the answer in the back of the book. Yes, it is. Okay. All right, number 59. All right, let's go ahead and do our multiplication. 2 cosecant, that's 4 cosecant squared x. And then 2 cosecant times negative 2 is negative 4 cosecant x. And then 2 times 2 cosecant is a positive 4 cosecant x. And then positive 2 times negative 2 is a negative 4. Then obviously these cancel out right here. So I'm left with 4 cosecant squared x minus 4. Now I would factor out a 4, and you're left with cosecant squared x minus 1. Okay? Now, cosecant squared x minus 1 is this whole group right here I just circled is the same thing as cotangent squared x. And I believe that's what the back of the book has. Yes, it is. So we're doing good. Okay, moving on, students, to number 61. Number 61. And let's see what the directions say here. Combine them and then simplify. Okay, so here we go. Let's go ahead. Looks like we're going to multiply the top fraction here by 1 minus cosine. So here's what we're going to do. Let's go ahead and take this and slide it over here. And let's get out our pen here and let's get rid of some stuff, so we have some room to work real quick here. There we go, much better. And here we go. Alright, now I'm going to multiply this whole fraction here by 1 minus cosine x. 1 minus cosine x. I'm trying to get a common denominator, students, so I can put these two fractions together, okay? Let me get a drink here real quick. So, with that in mind, I'm going to multiply this fraction here by this denominator over here, which is 1 plus cosine x. And here we go. My common denominator would be, let's see, I'd have 1 minus cosine x times 1 is 1 minus cosine x all over 1 minus cosine x, 1 plus cosine x, and then plus, and then 1 times this would give me 1 plus cosine x all over the same denominator. Now, okay, I did all of that. Now I can put my two fractions together, so I have 1 minus cosine plus 1 plus cosine. So 1 plus 1 plus 1 is 2, and then a negative cosine plus a positive cosine, they cancel out. So 2 over your common denominator, which is really 1 minus cosine times 1 plus cosine, which if you multiply your denominator out, you're going to get 1 minus cosine squared. And don't forget, 1 minus cosine squared is sine squared, okay? And now, what number was this? 61, I believe? Yeah. And now, 2, let me get some room here real quick. 2 over sine squared. Now watch this, students. 2 over sine squared would be the same thing as 2 times 1 over sine squared. And students, 1 over sine squared, the reciprocal of that would be 2 cosecant squared, because the reciprocal of 1 over sine squared is cosecant squared. And there we go. That's the answer in the back of the book, I believe. Yes, it is. All right, moving on to number 63. All right, same thing. Let's get a little room here. Slide this over and go to here and here and here and go like this. All right. Now, I want to get a common denominator, so I'm going to multiply this fraction here by this denominator over here. So cosine over cosine, okay? I'm going to multiply this fraction here by this denominator over here. So 1 plus sine x over 1 plus sine x. Now, cosine times cosine is cosine squared all over cosine x times 1 plus sine x. And then plus, and I'm going to be really careful here. I'm going to go ahead and leave these separate for now. Well, I'm not sure. Let's see. Cosine squared, I'm going to go ahead and multiply these together. And I'm going to save time and just tell you right now, if you multiply 1 plus sine x times 1 plus sine x, you're going to get 1 plus 2, let's see, sine x plus sine squared x all over cosine x 1 plus sine x. Okay, now when we go, students, in a second to put our two numerators together, I'm going to go ahead and do this. Now I'm adding my two numerators. Watch. I'm going to put my sine squared first, and then my cosine squared second, for obvious reasons, and then plus 1, and then plus 2 sine x. Okay, all of that's over my common denominator, which is this right here. I'm just going to bring it down like this. Okay, now look at this, students. I have sine squared plus cosine squared right here. So I'm going to get rid of that. I'm going to put a 1 there. Okay, now I have 1 plus 1, so I'm going to get rid of that. I'm going to put a 2. And now I'm thinking I can factor a 2 out of this pull out a 2 and I'm left with 1 plus sine x. Look at that. And then 1 plus sine x would cancel with 1 plus sine x, leaving me with 2 over cosine x. Well, then 2 over cosine x, just bring your cosine x up, but use the reciprocal function. 2 over cosine x is the same thing as 2 secant x. Let me check the book here real quick, and that is correct. There we go. All right, 2 more problems to go. And we're finally finished. Here we go. Number 65. Okay, they want us to eliminate the fact that we have fractions, so I'm going to multiply this fraction by 1 plus cosine y over 1 plus cosine y. Now I did that because of the reciprocal. The reciprocal of 1 plus cosine is 1 plus cosine. So here we go. Sine squared times 1 would be sine squared. Sine squared times cosine would be sine squared cosine all over. And if we multiply these correctly, we'll get 1 minus cosine squared. Okay, now 1 minus cosine squared is the same thing as sine squared. Okay, and so now if you look what you have, students, really, I would take the numerator if I were you, this right here. I would factor a sine squared out of both terms. So it looks like this. 1 plus cosine y all over sine squared y. And now these will cancel. And then you're left with 1 plus cosine y. And now you eliminated the fraction like they wanted you to do. And I believe that's the answer in the back of the book. Yes, it is. So we're doing pretty good there, okay? All right, last problem. Now, again, for me, students, I'm probably going to use the conjugate. I'm going to multiply the top and the bottom by secant x plus tangent x over secant x plus tangent x. So if I do that correctly, I'm going to get 3 secant x plus 3 tangent x. And in the denominator, I'm going to get secant squared minus tangent squared. Okay, now my trig identities, I better look back at those real quick here. Let me look at the answer in the back of the book so I know what it is. Okay, 3 times that. Okay, now let me turn to my trig identities. And what I'm looking at here is, well, we're basically done. We are done. If you look at your trig identities, you have this right here. You have 1 plus tangent squared equals secant squared, okay? But if you bring the tangent over and make it negative, then 1 equals secant minus tangent. So, secant minus tangent, right here. Secant squared minus tangent squared. So really, this whole numerator is over 1. So your final answer is 3 secant x plus 3 tangent x. Now, that's good enough for me. The back of the book factored a 3 out, and they wrote this for their final answer: 3 secant x plus tangent x. I don't care. I'm fine either way, but there we go. Okay, so I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.